Today's the day we're going to learn about imaginary numbers. Okay? Back in 4.2, when we were graphing, and I was really specific about the idea that when the graph did not cross the x-axis, I wanted you to say no real solutions, not no solution. Because when we talked about that, I said, because we're going to learn about imaginary solutions. And the first step in learning about imaginary solutions is learning about imaginary numbers. And so in order to do that, we have to talk about some examples first that we already are familiar with. And the first example would be something simple like this, the square root of 9. Okay? Go ahead and write that down and then write the answer to that. You know how to do this problem. Somebody explain to me the thoughts that went in your brain when you had to figure out what the answer was. Arturo, what do you got for me?
The square root of 9.
Yeah. Well, how did you know how to... What was your answer?
3.
How did you know it was 3?
Because 3 times 8 is 9.
Okay, so 3 times itself equals 9. How many had 3 written down as your answer? Okay, good. So at some point you had to think to yourself, what number times itself equals 3? Or another way to think about that is what number to the second power squared equals 9. Okay? Square root and squaring are what we call inverse operations. They are opposites. Okay, so when we think of the square root and we think of a number to the second power, we know that when we multiply 3 times 3, that equals 9. You multiply 3 to the second power equals 9. Square rooting and squaring are inverses. Okay. Can you ever take a number times itself? Actually, let me rephrase. If you take a number times itself, what kind of number will you always get? Raise your hand if you think you know. What kind of number will you always get if you take a number by itself? What kind of number will you get? Raise your hand. Any number times itself will give you what kind of number? Okay. Anytime we take a number times itself, you get a positive. So one of the things that we've talked about, some of you and I have talked about, is when you enter things in your calculator. Okay. This is always going to be positive 9. Yet some of you, when you type it in your calculator, go like this, which the calculator then does this part, and so you get negative 9. There's no way to square a negative number, because you can't take a negative times a negative and get anything but... Now, so the thing that we're talking about here, let's think about something different. Let's think about negative 9, okay? How can I get negative by multiplying numbers together?
Could you stood over there?
Oh my gosh, good. You're in the picture. How? Tell me how to multiply 2 numbers together to get negative 9.
Negative 3,
Negative 3 and 3, or?
negative 9, 1.
Well, if we flipped it around. Okay? In either case, my point is this. Okay, whether it's 3 times negative 3 or negative 3 times 3, that's going to give me negative 9, right? So what if I had a problem that asked me to find the square root of negative 9? Is there a number that you can multiply by itself that will ever give me a negative? Okay? And so this is sort of the basis of what we're going to cover today. All right? And so that's where we get into imaginary numbers, and we'll get there in a second. But let's go back to this. I'm going to put 2, I'll tell you when you can take a picture, but not yet. For a second. What was the issue here? What was creating a problem under here? The negative. The negative is the issue, right? And so what the imaginary number does is allows us to take way back at the beginning of the year when we were going over real numbers. We talked about the real number set. There's real numbers irrational, rational, integers, whole, and natural. We talked about that way back in the beginning of the year. That is the set of real numbers. Today we're talking about the set of complex numbers. So the set of complex numbers includes real numbers, but it also includes another set called imaginary numbers. So now if you want to take a picture of the screen, you can. Okay, so now here's the deal. We have the set of real numbers here. We have the set of imaginary numbers over here. That's what consists of a complex number. So every time, and you didn't realize this, because why would you? Every number you've ever thought about is a complex number. There just was no imaginary part. Okay? And so what we have to understand is, what is an imaginary number? Well, there is one quote-unquote imaginary number, and everything else builds off of that. And that is called I. Okay? I wrote it off to the side as a script because oftentimes you see it as a little script I. Okay? I is the imaginary number. And I'm going to tell you what the number actually is. Now, before I do that, let's go back to the care of that negative. I equals the square root of -1. You can't take a number by itself, multiply them together, and get a negative. We just talked about that. So what someone did a long time ago is they said, you know what, if we could just deal with that pesky negative, we could manage the rest of it. And so they decided, okay, we're gonna come up with this variable I for imaginary, and we're gonna set it equal to the square root of -1. And then if I can sort of pull that out, I can deal with the rest of what's under that square root just fine. Okay? Now, as stated on that Venn diagram, all complex numbers have a real part. That was the real part to all the numbers you've ever thought of before. And then we have an imaginary part. Now, like I said, to this point, there's not been an imaginary part. So it's been kind of zero is the way to think about it. So all complex numbers can be written in this form, a plus bi. And now, if b was negative, then it'd be a minus, whatever that was. But just like when we've talked about standard form of a quadratic ABC or standard form of a linear equation ABC, sometimes those can be negative, right? Same thing here. A can be negative, B can be negative. And so what this represents is A being the real part, and BI, anything with an I attached to it, is going to be the imaginary part. Let's talk about a problem similar to the one we looked at just a second ago, the square root of -9. We're going to look at the square root of -16. And you're going to have problems like this in your homework. Simplify. If only that negative was gone, we'd be fine. Because what's the square root of 16? 4, right? 4 times itself is 16. So what we do, and the way we think about this, is we think about, and this may be something you don't know, but when I multiply underneath a radical, I can actually separate that into 2 radicals. Okay, and the radical is the square root. So for example, I could think about this as 16 times -1. All underneath the square root, underneath the radical. Okay? And when I have multiplication underneath a square root, underneath a radical, I can actually separate those into 2 separate radicals. This is an important property for radicals, for square roots. Okay? A square root is a specific kind of radical. There are others, and we'll learn about those later in the next semester. Now we've learned what the square root of -1 is. What is it? What is this? I. This is I. The square root of -1 is I. And the square root of 16, we already said, was 4. So where I go from here is this is 4 times I. Or, another way to say that more simply is just 4i. So we went from something that we went I can't do anything with because there's no number that you can multiply by itself to get a negative, to actually simplifying it to get an answer. So as I said earlier, they figured out a way to just pull the negative away. Sometimes you'll hear me say pull the I out. If you pull the I out, then you can just worry about the square root of 16. And I like to use that phrase because it sounds weird. And sometimes you remember it. Okay? And so one of the things, even though I wrote it here, another way to think about this, okay, is if I pull the I out first, then it's not negative anymore. Okay? And then, of course, this is I times 4, but then that sounds like you're playing bingo, and so it's more like that. Okay? Just like with variables, we put the number in front. We don't put the variable first. Okay? So as you get better at this, you can jump from here right to pulling the I out, and then it's just positive, and you go from there. Okay? Question. The square root of -1, yes, is always I. Good question. Now, there's one other thing, and this is the part about this is one of the things in math that I love, because it shouldn't make sense. But if you think about it, it does. Okay? So we've already talked about this. I is the square root of -1. If I square I, okay, if I square this, here's what I have. Okay, if I have I squared, then I have this squared. Now, something we just talked about. Squaring and square roots are inverses. What does that mean? What happens with inverses? They're opposites, which means they cancel each other out. So what this means is, if I have a square root squared, they just cancel out. So the square root of -1 squared is actually just -1. And I just want you to think about that for a second. We had something that is not real. This is not a real thing. This is a figment of our imaginations. But yet we square it and it turns into something real. How can that happen? That's the math magic behind it, okay? And that's, to me, one of the things that's really cool about math. We had something that was imaginary, but yet when we squared it, it turned into a real number. Now, I'm just going to tell you straight up. Whenever you see I squared, immediately change it to -1. Immediately change it to -1. Whenever you see I squared. Because you're going to see I squared. And where we're going in this unit, 4, 4, and then eventually 4, 6, when we're going to solve quadratics using something called the quadratic formula, sometimes that's going to happen. Whenever you see I squared, immediately replace it with -1. Okay? All right. The last thing that we need to do, and the last thing that you'll be doing in your homework. All right. So we're going to do operations. We're going to do addition, we're going to do subtraction, and we're going to do multiplication. We are not going to do division. I'm going to spare you that. Okay. Now, the thing that's nice about adding complex numbers, subtracting complex numbers, and multiplying complex numbers is that your answer will always result in a complex number. And our process of adding, subtracting, and multiplying is exactly the same as if I was an x. Okay? So that's why I say treat it like it's a variable. Okay, I is not a variable. It stands for the square root of -1. It is the imaginary number. But we can treat it like one. And then anytime we have like terms, you can use it like it was an x or a b or a pick the variable you want to use. So we're going to look at 3 different problems. Okay? You can notice here that each complex number is the same for each problem. The first number is negative 2 plus 5i, negative 2 plus 5i, negative 2 plus 5i. So I have one complex number, okay, the same complex number. Then over here, I have a second complex number, 1 minus 7i, 1 minus 7i, 1 minus 7i. We're taking those same two complex numbers and we're doing three things to them. Okay, we're going to add them, we are going to subtract them, and we are going to multiply them. Those parentheses are sitting next to each other. We learned about FOIL, we talked about FOIL last week, and that's what's going on for C, okay? So go ahead, I want you to try to do A, and let's see what you come up with. This is as simple as just combining like terms. Okay, the I's are not going to go away for this problem, for part A. All right? Now, these parentheses are only here to cover, surround, identify that this is a complex number. Okay? Is anything being multiplied on either side of these parentheses? No. How about here? So I really don't need the parentheses. Okay, they're not necessary. They were there to identify I have a complex number, and then I'm adding them together. So I can drop them. They don't need to be there. Now, from here, it's just a matter of identifying which ones are like terms. Just like it was a problem we did before. Okay, so here's what that looks like. I combine negative 2 plus 1. What's negative 2 plus 1? Negative 1. Okay. What is 5i minus 7i? Well, that's as simple as going, what's 5 minus 7? And then slap an I on it. What's 5 minus 7? Negative 2. And then I slap the I on. And that's it. Okay? Now, some of you like to do where you're adding and doing the opposite. There's no two sides here. There's no equation here. Okay, so make sure you're not doing things like that. Just take the signs that you already have, combine the ones together that are like terms. Okay, so my final answer is negative 1 minus 2i. Now, what's the issue on B that we have to worry about? Because there's nothing in front of this that's being multiplied. So I know I can just put negative 2 plus 5i, and I don't need the parentheses. What do I have to worry about? Okay, this minus sign right here, you have to distribute it. Which a negative being distributed just changes all the signs. So this ends up becoming negative 1, it was positive 1, and this becomes plus 7i, and it used to be minus 7. And so then we can proceed the exact same way that we just did. Okay? So I have negative 2, and I have negative 1. Do I add those numbers or subtract those numbers? And how do you know? Negative 2 and negative 1. Do I add 2 and 1 or subtract 2 and 1? One of those. Okay, let me tell you. Why do you add?
Because a negative minus a negative.
Nah. Don't make it that complicated. Thank you. Elizabeth, say it again. Same sign. Add. Same sign, add, keep the sign. Okay? So that becomes negative 3. When the signs are the same, add the numbers, keep the sign. If the signs were different, then you subtract. And then you have to decide, is it positive or negative based on, were there more negatives to begin with? Then it's negative. Were there more positives to begin with? Then it's positive. Okay? Now, then I have positive 5i, positive 7i. So we can think about it the same way. 5 and 7, am I adding or subtracting them?
Adding.
because they're both positive, same sign, right? It's the same idea. So in this case, positive 12i. Now the last one is where we have to do FOIL. And the last one is where you're going to end up with an I squared somewhere. Okay? So remember our FOIL. We multiply the first numbers together. Negative 2 times 1, negative 2. The outside numbers together. Okay? Negative 2 times negative 7i.
Positive.
Positive 14i. I'm gonna move this and make a little more room here. Negative 2, positive 14i. All right. Then I gotta do the inside. Anything times 1 is the same thing. And then I have the last. The last one is where it gets tricky, okay? So 5 times negative 7 is negative 35, yes. I times I is I squared. And what should happen most of the time is that last term always ends up being an I squared. Well, what did I tell you to do whenever you see an I squared? Change it to negative 1. Okay, so this is negative 2. Now I'm going to keep them the same color. Plus 5i minus 35. And this is times negative 1. I'm still going to keep this the same for now. What is a negative times a negative? Positive. So right here I have negative 35 times negative 1. That is positive 35. Okay, so notice the I squared is gone. I have what we call constant terms. Okay, this is a constant term, this is a constant term, and then I have what we consider variable terms. So I just have to combine like terms like I did before. Okay, so I've got negative 2 and positive 35. Am I adding or subtracting those? Are the signs the same or different? Different. Do I add or subtract? Which is bigger, the negative or the positive? So that means there's more positives. So if I take 35 minus 2, that just gives me 33. Okay, then I've got to look at my other like terms. I've got positive 14i, positive 5i. Am I adding those or subtracting those? Adding. They are the same sign. So that is 19i. That is my final answer. Okay, so notice when I added 2 complex numbers, I got a complex number. When I subtracted 2 complex numbers, I got a complex number. When I multiplied 2 complex numbers, I got a complex number. Okay? All right, we have one more thing we have to look at, I think. Oh, yeah. Yep, it's fine. All right. Now, last example. Because you're going to have some problems like this in your homework. We don't need that period there, I guess. Now it's gone. Okay. Now, this is the one case that we're going to look at with a quadratic equation where I don't want the side to be 0. As we talked about before, we always want quadratic equation, we want one side to equal 0. Whether we're graphing it or we're factoring it. In this case, we don't want it to be 0, okay? And so the square root property, when there's only a square, an x squared and a number, where there's not a x term, thank you, when there's not an x term, this is when you use that. So we have a variable squared and just a number. When there's no x term, normally we have a trinomial or something and there's not one of those, okay? So this is what's called the square root property. We want to get the x squared by itself. So we've been talking about when you move something to another side of an equation. So I just take this plus 64, move it to the other side, and it becomes negative. Now, this gets to the general idea of what we've been talking about all day today. I can't take a number and square it and get a negative. There's no number that I can put in here that I'm going to multiply by itself and it's going to be a negative, unless you have imaginary numbers, which now we know how to deal with a little bit. Now, here's what's important. There are two numbers in here that will work. Okay, this is a little different from square rooting, because there are two different numbers that I can put in here. Normally, when we take the square root, we get a positive. Okay, that's called the principal root. When we have an equation, there's actually going to be two possibilities that will work. And so, in order to get rid of the squared, we take the square root, which we've been talking about as the inverse operation. But when we take the square root of both sides, okay, what we have to do, so here's what I'm taking the square root of both sides. You have to put a plus or minus in. This is a way to express one of them is positive and one of them is negative. It's kind of a shortcut of writing two different answers. Okay. Now, since we've been talking about this, and I have a negative under the square root, I'm going to pull the I out. Okay, this is the same as plus or minus I root 64. Well, we know what the square root of 64 is. What is it? 8, right? Because 8 times itself is 64. So in reality, what I have here is plus or minus 8I. And so when you see problems like this in your homework, get this number to the other side, take the square root, don't forget about the plus or minus, and then do the problem like normal. Okay, pull the I out, then take the square root, and then it's easy peasy.